Okay, let's not make this awkward. Okay. All right, we're doing quotient of powers. Quick question. What is quotient the answer to the problem of? I want to say Olivia. No, not Olivia. Shoot. Good luck. It would be Sophia? Sorry, name's cut off. Oh my God. You in the red shirt. Division. What's your name? Reese. God, I wasn't close. It's cut off. I'm an idiot. Great. Perfect for the video. Awesome. Yeah, it's division. Quotient is division, right? Okay. Thanks, Caden. Quotient is division. Just kind of as a recap of power, like what we had yesterday, looks like that. That really means 2 times 2 times 2. Okay. Power is going to be a product of repeated factors, right? Product is the answer to a multiplication problem. What this means is that you are multiplying multiple things, okay? Remember that the base is the big number, and it is the number that is going to be the common factor, meaning it is going to be the number that we are multiplying a lot of things by, okay? He just went. Okay. Yeah, just tell him he just got back. There we go. Thanks. The exponent's the little number, right? And that tells you how many times you will use the base in as a factor. Okay? This is the number that's being multiplied repeatedly. This is the how many times it's going to be repeatedly multiplied. Okay? This quotient of powers. Quotient is division, right? Now, I want you to think about this, and I can show you kind of the notes from yesterday, right? With our product rule, when we were multiplying bases with or powers with the same base, right? What did we do with their exponents? It's on there, right? We added them, right? Okay. So multiplication, that's product. Quotient is division. What do you think we are going to do with their exponents with this quotient of powers? Yeah. Do you agree that division is the opposite of multiplication? Right? Okay. What would then be the opposite of addition? Subtraction. That's what you're going to do with these. Okay? To divide powers of the same base, you're going to subtract their exponents. So, what that will look like is this. If I have 3 to the 7th over 3 to the 3rd, first off, notice this is a fraction, and every fraction is a division problem, right? This would be like a 7 minus 3, which is a 4. Okay? That's how this works. Now, why it works, because if I have something like 5 to the 7th power, that's really going to be 5 times 5 times 5 times 5, 7 times. Right? On top of 5 times itself 4 times. Right? One other thing that I want to put down here, because I want you to get used to looking at this, is times 1. Remember, we kind of did that yesterday, the times 1, when we had this, right? That's something that's going to come up, especially when we get to 0 and negative exponents. But in any case, I've got this set up, right? Can anybody tell me what happens if I take a number and divide it by itself? Nehal? You get 1, right? Okay. So 5 divided by 5 is 1, right? It'll cancel out. 5 divided by 5 is 1, cancels out. 5 divided by 5 is 1, it cancels out. 5 divided by 5 is 1, it cancels out. And all of a sudden, the only thing I have in this denominator is a 1. Well, Well, if I kind of clean this up a little bit, I've got 3 5s up here, and I've got 1 in the denominator. What happens when you divide anything by 1? You get the number itself, right? Well, check this out. Isn't 7 minus 4 3? Works, right? So that's why this works, okay? And knowing that this subtraction works is way easier than writing all of these 5s, at least in my opinion. If you like doing this, that's fine. I personally do not. I'd rather just use the rule, okay? The algebra, this should be an A. My typo has not been corrected, but it's it would just be m minus n. It's just saying forgot to do this. I want you to write this, okay? Zoom out a little bit. Be sure to do this. Oh, you can't even see it. When we subtract exponents, subtract from the top down. Okay? So if we have our fraction, right? If we have our fraction, you're going to subtract from the top down, right? 7 minus 3. 7 minus 4. Okay, subtract from the top down. Do you have any questions on this? Okay. So just kind of take a look at these next couple of examples here, right? Notice that they all have the same base, okay? Every one of these has the same base. Some of them have 2 different bases, and that's okay, right? But for this one, we've got 4 to the 8th power over 4 squared. So my rule, if I use it, top down, should be 8 minus 2. What is 8 minus 2? 6, right? Okay. Works with numbers just like it will with variables. Again, from the top down, so this would be n to the 9 minus 4. All right. What is 9 minus 4? 5, right? Then we get to this next one, right? And it doesn't look that easy. However, if you just separate this, if you just understand that these are all kind of separate things here, it's just doing one of these 3 different times, right? So if I subtract from the top down on this first one, 5 minus 2, I've got like a 2 to the 5 minus 2. My 3's would be 5 minus 4. And my 5's, wait a sec, this guy doesn't have an exponent. What's that one mean? It's going to be 1. I want you to write that in there. Honestly, right now, do this. Look throughout the rest of these other questions that we haven't gotten to yet. Find the ones that don't have exponents, right? Just before we even start doing this, find the ones that don't have exponents. Like I see one here. Put a 1 in. This one, this 3 doesn't have one. Put a 1 in. This 3 doesn't have one down here. Put a 1 in. This T doesn't have one. I don't know why these are so small down here. I apologize. Okay. But yeah, now we don't even have to think about, what exponents are for some of these, right? So if I take a look at this one, let me finish it. 5 is our base to the 2 minus 1, right? And then, that's the hard work. This is simple subtraction. 5 minus 2 is 3. 5 minus 4 is 1. You can put the 1, or you could just leave the 3 here. Student asked me last period if we put a 1 on this, would it be counted wrong? I won't count it wrong. I'd take the 1, or I would, take just the 3. I don't know what IXL does. No idea on that one. That'll be a thing that we can try out. And then 5, right? 5 to the first power. Okay? Take the next several minutes. I'll give you 3-ish. 3-ish minutes. Try these, okay? Remember how I said at the beginning of the period, I want you to try things. A lot of people didn't do their assignments last night, okay? Got to figure it out. Try this stuff now. Make the mistake now. Okay? See what we can do. Yeah, about 3 minutes. Now, this one's not finished. What do you notice about faces? Still the same. So you can actually remember the product work yesterday in some class. We'll go over all of that. Threes to the threes, the X's to the X's. How you feeling today? You feeling better? Good. You're gonna run into some things that I'm curious how you're gonna tackle. It's looking like maybe another 2 minutes. How do we have here? Oh, 27. We got plenty of time. I was thinking it was like 6 or something. Yeah, 2 more minutes. 2 more minutes on this. We'll go through. Elijah, how would you describe where the LV Island is? It's like, you know the front offices? If you keep going to the front office, it's like on the other maybe, yeah. I don't know how to describe it. Okay. Yeah, we'll figure it out. We'll figure it out. All right, let's take a look at this, okay? This one, not too bad, right? This one's pretty much the same thing as it was, right? So 7 minus 4, it's going to give me 5 to the third power. 12 over 2. Ooh, this is interesting. We didn't have one up there that was kind of like this. But I did say, like, I will say that as I was walking around, you guys did the thing that you needed to do naturally, right? Now, I know that 12 and 2 are not the same base. However, if you have 12 over 2, that means 12 divided by 2. And 12 divided by 2 is 6. So I think most of you guys naturally just did what you were supposed to do. Okay? And then these W's, same thing. 5 minus 1 is going to be W to the fourth power. Right? This one is just like the one up above. Negative 2's stay with the negative 2's, so it would be a negative 2 to the 5 minus 2, 3 to the 4 minus 1, 5 to the 7 minus 4. Okay? Shoot. 5 minus 2 is 3, not 5. 3 to the third, 5 to the third as well. Okay? And then down here, 3's have the same base. 4 minus 1, if I just kind of, again, separated this. 4 minus 1, this will be 3 to the third. X, 4 minus 2, remember we go top down on these. 4 minus 2 is 2. This one is like the one up above it where you're actually dividing. 16 divided by 8 is 2. 4 minus 1 is t to the third power. Now this one's interesting. What do you notice about all of these bases? Every one of them's the same, right? What you could do is you could use the quotient rule, which is where you go from the top down just like we've done on the rest. What I am choosing to do, actually, because it makes more sense in my brain, is I am going to use the product rule from yesterday, right? Because product just means multiplication, and these are all being multiplied on the top and bottom. So I'm going to add these exponents up. 5 and 6 is 11, plus 4 is 15. And then I'm going to add these up. 2 and 3 is 5, plus 3 more is 8. So this will be 6 to the 8th. And then when you subtract 15 minus 8, you get 6 to the 7th power. Or as first period said, 6, 7. Ha ha ha. I don't get it, but you guys love it. So whatever that means. Fun fact, I set that trend, by the way, the 6, 7 thing. That was me, because I made these notes 2 years ago before it popped off. So you're welcome. You're welcome. I know, right? Right? Okay. So there we go. Cool beans. All right. That's it. There's nothing on the back. This is quotient rule. It's just subtract. Okay.